Since this is a very time-constrained activity, we will start very promptly. I am Pete. I am your lovely host for the evening, which means I just get to introduce you to all the fun stuff we're going to do tonight. So welcome to HOTRFC. This is an IETF activity. Therefore, it falls under what we call the Note Well if you are a new participant. This means that by participating in this group, you are agreeing to participate under all of our rules and guidelines. There's a lovely list of them here. If you are in particular aware of intellectual property contributions that need declarations, you have a responsibility to do that. If you do not know what those obligations are, you might want to read over the documents listed down at the bottom of the slide there. Intellectual property is not the only thing we care about. You understand that there are going to be video and audio recordings of this, that personal information will be handled in accordance with the privacy policy, and that you agree to work respectfully with other participants. If you have questions about these things, let someone know and go chat about them outside of the room. Next slide. So we do want to remind you that all of these activities that we're engaged in here are under the IETF guidelines for conduct, the IETF anti-harassment policy and procedures. If you have any concerns about any behavior that you see, please let the appropriate folks know. I happen to be on the Ombuds team. You're welcome to contact me. You are also welcome to contact any of the leadership who can help you out with that stuff. We're going to try and maintain an environment in which people from different backgrounds and identities are treated with dignity, decency, and respect. So please do. You must not engage in harassment, and if you believe you have been harassed or notice someone else who has been harassed, please do contact the Ombuds team. All right. As far as participation, for in-room folks, please make sure to sign into the session. You can use the little phone app or you can do it on your laptop, but please do turn off your sound so the poor folks remote don't get weird feedback. You can join with the Meet Echo Lite client. And you do want to use the join the queue if we were having questions, which we were not in this session, so don't worry about that. Again, keep the audio and video off if you're on site. For remote participants, please make sure that your audio and video are off unless you are recognized by the chair to present something. And please use a headset if you're remote, because that will make life much easier to hear you. So here are the ground rules. HOTRFC is how you make a request for conversation. So these are short talks that will invite people to talk to you about topics you're interested in. Each person gets exactly 4 minutes from go to please applaud. You guys are going to do the applauding part. At 4 minutes, we will start applauding immediately.
Let's do a practice.
Ready, everybody? Please applaud. Okay. So, yes, 4 minutes is really the limit. We do want to get out of here in a reasonable amount of time. We don't do questions in here, but each person will provide follow-up info, and in-person attendees can follow presenters to the bar or wherever else you want to have a quick chat with people about their topic. So you can follow along. We've got all of the slides for the presenters in the data tracker, so you can go take a look at those slides as you see fit. So are we ready? All right, please applaud. A little good. We'll get started. And our first person up to bat is Jean. You ready? And the word is go. We can help if needed. There you go. Okay.
Do I need the microphone?
Please.
Okay.
So the remote people can hear you.
It's running. All right. So what I wanted to try to discuss today or to present to you was the idea that I had a few weeks ago about what would a world without SDOs, without standard developing organizations, could look like. whether that word will be materialized. And in particular, I wanted to just flavor it a little bit for the IETF this time. So I was first thinking about what was happening before the IETF. And so if you thought about what was the state of designing protocols in the TCP/IP stack, so you would have a lot of experimental proprietary situations, a lot of ad hoc solutions. Think about the lack of resilience between nodes, etc. And so it made a lot of sense to invest time to put together people in one single room, try to get to agree as to what would be the parameters that you would like to negotiate on the standard or with a proposed standard, and move forward with that. And essentially what that brought was having collaboration, some ensure interoperability between systems, and you would have cost reduction, et cetera, et cetera. And so the way I look at it is a bunch of people were coming together to agree to help machines to talk to each other, because at that point, the machines were stupid enough to not know how to talk to each other. So basically, machines needs us at the moment. Now, the question that I'm asking myself is whether that actually changes with the technologies that are coming over. Will we reach a point in which the collaboration between a vast amount of people having to move into one single point, like in here in Vancouver, for instance, will be still necessary or not? So right now, we establish protocols to be able to have a number X of systems communicating with each other. But what happens the moment that companies may have their own agents being able to talk to each other and solve those problems ad hoc, point to point, at very low cost? And so I have the feeling that we're going back to ad hoc solutions, very likely to proprietary ones, and the cost reduction will be relative. And I'm not sure if we might be facing in a near future the end of what we understand as protocols nowadays. And so I have these questions that I would like to discuss with people, see what you guys think about where technology is going, where these things are going to be happening or not. So would it be the end of protocols? What could be the role of the IETF? Should we evolve into that? Are we going into an upper layer to try to give some very generic or general regulations or indications as to why or how those ad hoc implementations should look like and what they should and should not do? How far we are from that scenario? And if that scenario ever happens, what are the kind of things that we should be preparing in advance to avoid certain possible negative side effects? That's my email if anyone wants to talk with me. Tomorrow I'll be running a side meeting to go a little bit further, because of course in 4 minutes I cannot explain all the things that I've been looking into in that particular topic. I would hope to be able to discuss this better. So Tennyson tomorrow 3:30 to 5. And since Pechakucha is canceled, that there will be no extra conversation. And I got 12, 11, 10 seconds. You can applaud now if you want. Thanks.
All right, Stuart and Nate, you are up to bat. Or just Stuart. Are you ready? Would you like your clicker?
I am.
Click along.
So I am here today on behalf of Nate, who can't make it. So this is something that came up at the last IETF. Nate and I were talking about this. Nate works for Garmin. He's doing some things with multicast. He had some problems with all the multicast receivers have to have the same port number to receive the UDP packets. And I said, oh, it's funny you should say that. When I was a student 25 years ago, at SIGCOM, I gave one of the outrageous opinions talks where I said, it's stupid to use UDP for multicast. You should have a different protocol because the port number is irrelevant. And then I forgot about it, and Nate came up with a solution. So, little reminder, for unicast traffic, port numbers tell you which endpoint on the system the packets are going to. And arguably, It was a mistake that that's not in the IP header, but we fixed it by having this other thing called UDP on top, which tells you where the packet is going. For typical unicast applications, they're allocated statically by IANA, but it's a scarce resource. And that static allocation doesn't work if you want more than one thing, right? You want two web servers running on the same host. They can't both have the same port. So that's never worked very well. Dynamic allocation and advertising it with DNS service discovery means you can have as many HTTP servers as you want on a host and discover which port they're on. But when it comes to multicast, you can't have each thing on a different port. And that leads to this problem that multicast applications need to get static ports allocated, but you still have this problem. What if you want to run two on the same host? And then the insight is, but wait, why are we doing this at all? The multicast destination address, the group address, tells you who the recipients are. You don't need to further demultiplex with ports, which is why I thought we should have another protocol, multicast datagram protocol that doesn't use ports. Nate's insight was, well, that's going to be a big change. We're not going to change all the kernels. But how about we just do this hack? We just pick one or two ports that are just dummy ports. They're ignored. They mean nothing. And we have all the applications. Oh, this is a bit of an overview. Yeah, multicast addresses can be static and dynamic, but this is the key point. Just have all the applications join the right multicast group address, and we want those multicast group addresses to be unique because the whole internet infrastructure is building its forwarding tables, it's doing routing to get the right packets to the destinations that want them. But once they arrive at the destination, throwing it away because the port doesn't match is incredibly wasteful, right? We've already expended all the internet resources to deliver the packet. So Nate Carstens proposes we just take the last two ports of the current dynamic range, all multicast applications use those ports. They use SO reuse port and or SO reuse adder to share them, and they just become a dummy 16-bit field in the packet. They're not used for anything, but for compatibility reasons, UDP packets have to have a port, so we'll stick a port there. But in fact, that's not what does the demultiplexing. The destination group address is what does the demultiplexing. So I think the reason I agreed to support this, I think this is an elegant solution, works with today's operating systems, and solves the problem. So please come to the PIM session on Wednesday to talk more about this.
Next up, Swapnil.
Hello, I'm Swapnil Sheth, and I'm joined here by my colleague, Andrew Kaiser. Our co-authors from ENS and Blue Sky were not able to make it to this IETF.
Point this way. Oh, you got it. Okay,
And so what we're here to talk about is DNS integrations. DNS integrations allow or enable a DNS domain name to be used as an identifier within an application or a protocol, right? We know this very well. We know the use cases, email and website, right? But over the last few years, what we have seen is there is a lot of demand on use cases for DNS domain names within new applications in blockchains, Web3 applications, decentralized social media applications, to name a few. So that's quite interesting and exciting to extend the utility of DNS domain names, but we want to make sure that that's done in a responsible manner. And that's how we get to responsible DNS integration. And what we mean by that is it's not just enough to have your DNS domain name act as your identifier within the application or protocol, but also be able to extend, it's important to extend the security and reliability of DNS into the application, into the new use case, right? And so what we've been doing is, as part of research, studying these different integrations. And so as listed here, we've studied Blue Sky, which is a social media platform that allows you to use your DNS domain name as your social media handle on the platform. ENS, which is Ethereum Name Service, and that's a blockchain-based naming service, a naming application that allows you to import your DNS domain name so that that can act as your digital wallet identifier, as an example. And last is Microsoft GitHub, which is, we all know GitHub. GitHub has something called GitHub Organizations. If your organization has a GitHub page, you can associate your domain name and also verify that you control the domain name, which allows you to get a green check mark so as to build trust with your end users. And so we published some measurement studies to understand if these integrations are responsible. And as part of our Diner 2024 presentation, you're welcome to take a look at that slide deck that I've linked here. There are three findings. One is there is a lot of interest in integrating with DNS into these new applications and protocols. Second is that all these integrations have been done in a variety of ways, where people are trying to reinvent the wheel. And third is that there is definitely a gap in understanding of how DNS works in these different communities. And so what do we want to do is, give them some guidance in terms of how to integrate so that we do this responsibly. And that's the draft that we just published last week. That draft goes over motivations to use DNS domain names, global consistency, stability, flexibility, but also comes with a lot of challenges. And so we have listed in our draft in detail some of these considerations that you see on the screen. And the one that I can talk to you about today briefly is the domain name life cycle, right? So we all know domain names, once they're registered, they have a life cycle. They can be transferred, they can expire, or they can be deleted, right? And so if a domain name is integrated into one such application, how does this application track the domain name lifecycle and synchronize it?
Thank you very much. Next up, Andrew. Andrew, there he is. We are ruthless with the timer.
I love it. Showtime. Okay, I'm here to talk about an MTL mode draft we wrote up for DNSSEC. So MTL mode is a way to address the issues that large post-quantum signatures will introduce to some protocols, and also the processing overload. So how does it does that? Basically, use Merkle trees. Not a single Merkle tree. It can be a Merkle tree node set with multiple tree roots. And so what we do is use the Merkle tree to be able to prove membership of a message, in case of DNSSEC and RR set, that it's in the zone and that it's been signed. But then you got to bind it into the DNSSEC trust chain. So what you do is you take the roots of the Merkle trees and you sign them with a post-quantum signature algorithm. And so normally, if somebody's holding that sign, what we call ladder with those roots, they can then, if the authentication path authenticates to a rung in one of those ladders, then they can show that you've got the chain of trust from the signed ladder with the DNS key, and you can show membership. So unique approach. So there's a number of benefits that we see that. So it can address mainly it's hard to transmit large things over UDP. It's not reliable. The memory footprint of the zone for large signatures could be huge. And the CPU load for signing is tough, like Sphinx Plus takes quite a while to sign. So we have our draft that we've evolved over time. And we also looking for resilience with this approach. And we think it's implementable. Hash functions are out there. You can see the other types of benefits. So the drawbacks are, there's the protocol update, this two-step process of authentication. So we have a draft that defines the signature formats, even has 0 options, so it can be utilized. And we have a detailed examples in the draft of an example zone that's been signed. So we have an IPR declarations that we've done according to the IETF standards. So our next steps are basically we're asking for the community out here to review this draft. It's an early stage draft. We're just defining the protocol elements. And what we want to do is get implementations. We want to be able to do interoperability testing. And there are some test beds being formulated. And we also would love to have some of the aspects of applying this in the real world. We need the expertise of others who are familiar with DNS, particularly in the resolver community, the software development for name servers, authoritative. We get their feedback and perspective of where we should go with the draft and what additional things it needs to address. So with that, thank you. I finished early.
David, start making your way up. Would you like the clicker?
Oh, yeah, please. I'll do this that way. Hey, can y'all hear me? Cool. I'll try not to hold the microphone. I tend to drop them. Okay, my name is David. I'm here to talk about authorization and more specifically a language called Alpha 2.0, which is a proposal I'm making at IETF. And if it's called Alpha 2.0, it's probably because there was a 1.0 before that. Good point. So first of all, let's just take an example. Here's Mario. He's 25. He's Italian. I know it's a little stereotypical to have him called Mario, but anyway, apologies. And all these things are actually things that the person is proving. They're authenticating something about themselves, right? It could be their identity. It could be their date of birth. When you go drinking, the bartender doesn't really care who you are. They just care that you're allowed to drink wherever you are. So the age of 20 in Canada, 21 in the States, and 18 in lucky places. So that's all just authentication. It's pretty straightforward. There's lots and lots of standards around authentication, including here at IETF. OAuth, of course, and the many derivatives of OAuth. SCIM is another authentication protocol or related protocol. SAML back in the day, so on and so forth. Very mature, very well understood. Lots of innovation happening into things like strong authentication, so on and so forth. But what about the next slide? There we go. Thank you. What about authorization, right? Now that we know who you are, what it is you represent, now that we know that you're 18 or 21 or 25, what is it you can do with that information? What is it you're trying to do? In the case of Mario, he's trying to enter Canada to go to IETF, right? Is he allowed to go in as an Italian citizen? Can he travel to Canada? Is he on a blacklist or an unwanted list? Okay, so these are all the things that authorization is trying to solve, just making sure that you can enter Canada as an example. Side funny note, weed is federally legal in Canada. It is stately legal in the state of Washington, yet you cannot cross the border with weed. Don't try, you just can't. Because it's not federally legal in the States. And the border, although it's at the state of Washington, is actually a federal border. So how do we solve authorization? My friend and peer Alex Babineau put this graph together. What you really want to, if you get the slides later, you can look at it in depth. And I put a link at the bottom where you can find the full-blown picture. But there's two big models, MAC and DAC. Mandatory access control is whatever the enterprise dictates, the government dictates. It's things like you cannot drink if you're not 18 or 21, versus DAC, discretionary access control, which is more along the lines of, I've got a Google Doc, I want to share it with you. There's no real policy around it, I'm just going to share it with you. And under MAC and DAC, there's different ways to tackle authorization. Things like RBAC, role-based access control, ABAC, attribute-based access control, REBAC, relationship-based access control. It's a lot of backs. They really have your backs. It's a very, very rich environment, many different ways of tackling authorization. There's a messier picture here that shows all of the standards that exist. And what's interesting is on the left-hand side, on this side, you have all the vendor-specific or industry-specific standards, and on the other side, you have all the technical standards, the IETFs, the OASIS, so on and so forth. This is kind of a timeline of how authorization has evolved over time. It's not new. We've been at it for the past 30, 40, 50 years, depending on what model you pick, and it's still evolving, especially in the past few years. If you go to identity-related conferences, you'll see a lot of new things happening. And that's kind of what sort of worries me, is that I don't really want to reinvent the wheel. I just want to make existing standards better, which is why I'm talking about Alpha 2.0, right? And Alpha is an abbreviated language for authorization based on ZACWL, much simpler syntax, much friendlier on developers. A lot of companies use Alpha today, my company, Axiomatics, but also bigger companies like Salesforce, Thales, Huawei, Rock Solid Knowledge, and all their customers. Why Alpha 2.0? I want to make it easier on developers, make it easier on everyone, get rid of the legacy of ZACWL, promote reuse. Who's interested in Alpha 2.0? A bunch of companies, including bigger names like Ping Identity, and I'm out of time. I'm good.
Rich. Go.
Okay, hi, my name is Rich Sauls, here to talk about Quick TLS and encourage people to help contribute on ideas and code and anything else. Quick TLS was a fork maintained by Akamai and Microsoft. All we did was add patches came from Google that enabled other quick implementations. I think at least 6, maybe 8 or 10 quick implementations can run on top of it. OpenSSL decided to go the other way and do their own quick implementation. Not so great. So what we're changing is we're going to allow outside contributions. We're going to follow the boring SSL model in that we're not going to treat OpenSSL as upstream. We'll pull down security fixes. We will make sure that the FIPS provider still works. We'll remove silly things, VMS. We'll address some of the performance issues, and we will have close collaboration with the other major forks. They owe me. Okay, so why change? The OpenSSL project is all about quick these days. Other people have made other pull requests, see them languish. They have to keep pounding, hey, would you look at this, look at this, look at this, and so on. And the IETF is about more than just quick. Surprise. We need you. We want people who are interested in writing code, documentation, contribute ideas. If you know of cryptographic or other things within the IETF that are related to security, if you're a process wonk, like a former IAOC member, help set up the governance. If it succeeds, we'll turn it over to an Apache project. There's the project link. There's the email list for setting up the governance of the project. Get in touch with me. As they say, I'll be here all week. Please tip your waitresses and bartenders. That's it.
Everybody get Rich a beer for doing it in half the time. Nick, you are up. Sneaks up behind us.
Hello, hello. Hey, everyone. I'm here to talk about a draft that we have put together with some co-authors, including folks who couldn't be here, Louise, Brian, and George. The topic at hand is privacy and privacy on the web in particular, privacy policies and privacy settings. These things are very inconsistent. This is something that's not standardized across the internet. There are certain privacy policies that that are not even machine readable, that have to have a special renderer to open up to find. This is wildly inconsistent. But why are these here? These are happening because of various legislative rules, consent rules. So in order to collect information on a website, you have to get consent. So there was a previous ePrivacy Directive Consent 2002. It's been updated 2008. GDPR has this as well. There's certain aspects that have to be clear with respect to consent. So freely given, unambiguous, specific, informed, limited purpose. And as of today, these are implemented in widely different ways. There was a previous effort to try to formalize this at the W3C. It was very complex. We're proposing a very simple solution called privacy.txt. And it's inspired by some of the other .txt files that we've come to know and love, ads.txt, robots.txt, security.txt. It's very simple. There's several different sections here. So, and these are usually the aspects that are difficult to find. So, who is the entity and what is the privacy policy in text form or as an HTTPS link? What is the contact address for the privacy contact for saying opting out of personal data deletion or opting out of third-party sharing? How do you find these things? These are actually very difficult to find usually. There's also banner information. Is there a banner on the site? What consent style is implemented in there? And then there's a section for cookies, which lists out which cookies would be presented and some of their statistics. So the advantage of this is that it is machine readable, very easy to adopt. No changes on the user side are necessary, doesn't interfere with browser functionality, and in the most part, it does help websites fit into GDPR compliance and do this correctly. And if widely implemented, this would introduce a lot of transparency on the web. So in support of this draft exists. You can take a look at it. It's been submitted, but it's also on privacytxt.dev. In addition to that, we have a data collector tool and a cookie compare tool that we built to automatically create privacy text files from scraping and verifying the validity of privacy text files. These will go under /privacy text or under well-known. And this is supposed to have a real world impact if it gets adopted. So it's empowering users to have a better user experience when trying to understand the privacy policy of a site. It helps websites comply with GDPR, and it facilitates auditing. And with this, GDPR compliance on the web is relatively low. Privacy text is one solution. I know this has been tackled in various ways, but this is an attempt to do so in a very simple to write way. And these auditing and generation tools are very simple. So what are we looking for? Any interest? First of all, reviews of the draft. The draft's been submitted. Anybody wants to email the authors, we would love to hear any feedback from this. If you're interested in working on this and collaborating with us, working on the tools, we're very open to this as well. And yeah, any feedback on the document or path forward.
Thank you. Pascal. A clicker. Ready? Go.
So, everybody.
Close to the mic, please. And you can read here in front of
So,
you.
this project is called Online Telesecurement, and it's achieve low power, high security personal servers. The motivation. So, what we want to do, we want to develop online vault for internet users, let's say individuals and small and medium company. And the main idea is to use online securement. You all know you have 10 billion securement are manufactured every year, among which 6 billion of Java card, and this Java card can be programmed with a subset of the Java language, which is called the Java card. And so you all use securement mostly in your bank card, on your e-passport, and you know that it's very difficult to break this kind of device. That's the idea. So the security level is highly security level, AL6+ according to common criteria. So we use open technology. Basically, we want to open non-disclosure agreements and this kind of stuff. And we also want to use open hardware, things like Arduino, for example, when it's needed, because hardware is an important part for this kind of server. And the kind of service we target key management services and secure storage.
Please speak a little closer to the mic. Speak closer to the mic.
Yes, sorry. And so there is a draft called TLS-SC, which means TLS for secure element. And basically, TLS for secure element is a TLS 1.3 profile using pressure key. Pressure key is 128 bits, so it's high security. And we target two kinds of servers. The nano server, which really nano server is basically a secure element, and TCP/IP socket. And personal server are based on it's based on grid of secure element. And so then it means you have a TCP/IP socket that manage a set, let's say 32 secure elements. And so every secure element is identified by a uniform resource identifier. And so it's come from the fact that we have a TLS server inside each secure element. And so we use a pressure key as a secret, as a root of security. We have a secure channel, end-to-end secure channel with the secure element. And when routing is needed, we use something imported from TLS, which is called TLS server's name, and we'll call that secure element name. And we put it in something which is physical and which is collected upon reset, which is called the answer to request, or so you get something, a 15-byte field. And we use that for routing, and so it's give you a kind of uniform resource identifier. So this is an example of personal server. For personal server, we use, for example, I2C bus. So we use which something's called the secure element processor. And so the secure element has two addresses. One is physical, which is the I2C address on the bus. And the second one is a server name for TLS. And for nano server, it's different. We just have some SOC. It's very cheap. And we just use a 5Y ISO 7816 bus. And so you have a single secure element connected to the internet. We have low power conception, and it's illustrated over there. And so you can, for example, use solar panel to feed it. And I'm done. And so we are looking for people interested to develop services.
Thank you.
Thank you very much.
Daniel first. Ready?
Yes. Yes.
Go ahead.
Go ahead. Yeah. Actually, we have a couple of use cases over one which leads to higher performance that cannot be provided by the current technologies. And actually, traditionally, the massive data will be processed in local servers. But now more and more use cases where there will be massive data transmission will happen among multiple sites and multiple DCs. So there's new requirements of the wide area networks, which will be needed for these use cases. When it comes to multiple sites, there's a long distance transmission between two sites. For example, over 1,000 kilometers, such as the high performance computing for scientific research and distributed storage, and data express service, and multimedia content production, and the data backup and disaster recovery. And the second use case is the multiple DCs interconnection for the collaborative training across multiple DCs. And objectives and requirements of these use cases. What does the characteristics for high performance wide area network? The first one is the massive anything flows data with large burst, which have to be have to coexist with a lot of services and with dynamic flows. And because it's wild area network is involved. So there's long distances to the multi-hops and paths and diversified domains between the DCs and the sites. The objective of the goals for high performance wild area network is the ultra high bandwidth utilization and ultra low packet loss ratio and no latency and jitter. Like, when it comes to gaps for the existing technologies, the optical fiber direct collection is because to the limited scale and the cost. And the DC technologies such as PFC, there's just a slow feedback and high round trip and time latency and jitter. And there's 3 routing technologies, ECA and ACMP. Worse, the network is passive and unaware of the status. So it requires the coordination with the end systems. Network resources would be insufficient with no utilization rate. It requires improving bandwidth utilization. And long distance transmission requires ultra low packet loss, latency and jitter guarantees. And we have set up a site meeting on Tuesday afternoon, and we will have more discussion on detailed use cases and trying to identify some common requirements and identify a rough consensus of what IETF could do and what's the next step if possible. Thank you. Everybody can applaud. Thank you.
Yay. Always extra points for finishing early. Xipeng. You have your clicker.
So my name is Xipeng Xiao, and I'm the V6 Op co-chair. So if you want to find me later, you know where to find me. My topic is about IPv6 performance comparison with IPv4. And when people hear that, you know, one of the first questions came to their mind is that why would IPv6 have different performance from IPv4? And the answer is that IPv6, first you have no net. So you have certain advantage. But because IPv6 is relatively new, I think that at least for the network administrator, so because people don't know IPv6 as well, they may make some mistakes. And as a result, IPv6 have a certain disadvantage. So overall, I think that from the stat of APNIC, we already know that from the end user's perspective, for worldwide average, IPv6 have an advantage on latency, but have a disadvantage on the connection setup rate. So, okay, so now you say that, okay, if there's a performance difference, what's the big deal? The big deal is that if IPv6 have worse performance than IPv4, then in a dual stack environment, a happy eyeball will pick IPv4 and will not use IPv6. And worse, because happy eyeball protocol hide the problem from the end user. So nobody even report the problem and the network administrator may not even know. So you may end up deploying dual stack and thought that you are using IPv6, but you are not. So here is what we are trying to find out. What we are trying to find out, is there a performance, really a performance difference? So what can we compare? Between a dual stack host, a dual stack source, and a dual stack destination. If the end-to-end process is like, okay, first you need to do the DNS, and then after the DNS, you will set up the connection. And if the connection is successful, you'll try to find out whether there's a difference in packet loss rate, etc. So this is the whole process that we want to compare from the DNS performance to connection setup success rate, to connection setup speed, and then to the connection's packet loss rate. And at the end, if there's a packet loss, where exactly is the packet loss? Is it in the sender's domain, or in the transit network, or at the destination domain? And if you can collect this kind of statistics, then you will find out that, okay, if IPv6 performance is worse, where is the problem? Is it in the source or in the network or at the destination? You will find out. Here is how you can help. First, we need somebody to review the test case. For example, here we propose the test case, but some people say that, oh, they have opinions that, whether this is the best way or not. We would like to hear that. We need people to write the Python script because, things need to be, automatic as much as possible. We need people to contribute the probes. For example, if you have a dual stack host, you have a dual stack laptop, then I think that you can help. Almost everybody can help, or you can just help with RIPE, credit, so that we can use the RIPE Atlas probes. You can also help to analyze the result, and in the end, write up the result to public draft.
All right, Bill, do you want to turn on your microphone? Make sure we can hear you.
Yep. Howdy, y'all.
Yay, and just yell out next slide when you're ready.
Indeed. Very sorry not to be there in person. I fly out early tomorrow morning. I'll be there by lunch. So I want to talk just a little bit about the whole digital emblem thing and the work that's going to, we hope, get moving into the IETF. Next slide. So when people are talking about digital emblems, what they're talking about is these markings that are needed to indicate things under international law. So really quickly, clockwise from the top left, there's somebody with a press badge on of the sort that you would wear in a battlefield or whatever. The next one with the orange background is an ISO container marker. Then you've got UN blue helmets. The 4 markings on the cardboard carton there are components of chemical weapons. The end of the shipping pallet there is branded. This is a hot metal on wood brand with variable data in it. And that's required for any piece of wood that crosses a national border. The blue and white shield there is what UNESCO puts on a World Heritage Site. Then there's all kinds of markings for radioactive fuel or waste if they cross national borders, and the orange bag there is a diplomatic pouch. Next slide. So what all those have in common is that they're physical markings right now, and people are sort of gradually trying to figure out how to digitalize the markings. And customs agents are terrified that everybody is going to do these in different ways, and this has already started. So there are customs agencies that have something like 30 different scanners already sitting around to do verification of different proprietary markings. So the idea here is you have somebody issues a marking, they sign it. It is in the form of this digital emblem, which describes an asset. A validator who wants to figure out whether all this is legit validates the signature, and they validate the description. If they validate the signature and the description, they've got a link between the issuer and the asset. Next slide. So there's a binding of the issuer to the asset via the digital emblem. And this slide just talks about everything in generic terms, which you could implement in JSON or whatever. Then on the right-hand side, there are all the different ways of moving the data between the validator and, wherever they're going to get the digital emblem from. Next slide. This is the teaser that you will not see on Wednesday, which is the example of how you could implement this entirely on top of the DNS if you didn't feel like, for instance, doing it on top of JSON. Last slide. Please come to the Regency CD Wednesday morning if you want to chat about this. There are a zillion things to talk about. We have 2 hours. Would love to see you there. Thanks a lot.
Early applause. Yay. Thank you, Bill. Manu, are you ready to go?
Yep, I'm here. I just
Take
need
your
the clicker.
clicker.
Hold on. How does this work?
Got it?
This works. Great. Hi, I'm Manu Fontaine. Over the past few meetings, I introduced the work that we're doing on the Universal Name System and the Universal Certificate Authority. I want to continue that conversation. And really the goal that we are pursuing is the creation of an information space like the web, but that is architected from the chips up to have least trust principles built in. Where we're coming from, we are a public benefit startup. We are venture backed with some money from Paladin and Akamai, and then we also got some funding from NATO Diana and the DHS Innovation Group to build a messaging application on top of this information space and to build a privacy-preserving cryptographic wallet for DHS. So why least trust, and what do we mean by least trust? Because we believe that's North Star that we should all agree to. We think it just makes sense to try to minimize reliance on human trust and automate security everywhere. And so we systematically follow the principles of least attack surface, least knowledge, least authority, and least privilege. And to do that, we start at the chip level, at the physical computing infrastructure level. We leverage confidential computing chips, trusted execution environments, so we can use, RATS principles, remote attestation, verify the chip, verify each and every process running on the infrastructure, verify the cryptography that run in these processes, and then be able to verify the information space itself. And so that's what we use, and we built this universal name system. So it's like, imagine a naming system for every entity in the universe, people, organizations, physical things, digital things, a unified namespace. It's cryptographic. All the identifiers are cryptographic identifiers. And then the UCA is the automation of key management for all those entities. And that gives us the ability to solve things like provenance, integrity, authenticity, reputation, confidentiality, and privacy within the infrastructure. It looks like this, very much like a hierarchical, recursive, chip level, process level attestation and verification network that automatically generates decentralized identifiers and then automates pairwise cryptography. I need to go a bit fast here. So lots of stuff to say there, but essentially any organization will be able to deploy servers and software and then run their own, what we call agents on the infrastructure. When you take that diagram and you fold it onto itself, you see that what's emerging more like a mesh network, where every connection is, pairwise, all cryptography is automated. There's not a single human inside. There's no insider at all. It's fully verified, fully automated, quantum resistance, and all that good stuff. So because every entity and every agent has their own keys in a inherently least trust infrastructure, they can generate their own encryption keys. Every entity now has its own information space that is encrypted with keys that no humans have access to. We call that information isolation, which is kind of an extension of the concept of process isolation, where every individual process can actually have its own secure and isolated information space, fully encrypted from the rest of the world. So we're going to have a side meeting on Wednesday. We want to continue that conversation, give you an overview, and then updates on the latest stuff that we've built. We believe that eventually this should find a place somewhere at the IETF. We want to collaborate. We want to discuss how this type of infrastructure could be managed and governed through a coalition of companies. Thank you very much.
Thank you. We're making good time here. Jin? Whenever you're ready. Well done.
Ready?
Yep.
So my name is Chin Wu, and one of the green ball program. So I want to give a quick update of this green ball for activity in this week. And as we know, the power management is not new, already get adopted in the enterprise network, such as smart building, automation, IoT power management, together with sensor data connected from the IoT device, like temperature, humidity data. However, the power management in the enterprise is not a focus of today for this green bulb. Actually, we more targeted to network operator who manage a large scale mobile network, backbone network, data center network. With explosive growth of the network traffic and rapid development of network technology like 5G or AI computing, the network capacity and site are continue to increase, and the AI computing network infrastructure actually consume much more energy and power, which drive tremendous growth of equipment energy consumption cost. In the meanwhile, actually large proportion of the vast amount of the energy to be consumed are unnecessary waste. That's why actually more and more network operator actually seeking for the automation tools and a solution to better assess and control energy consumption across the whole network. So the target device or device component we focus on is the one to consume most of the energy. Actually, for example, in mobile network, we can focus on pure network device, and also we consider like power distributed unit combined with switch server in data center network. So the typical use case is provide energy consumption heat mapper to better understanding where to consume so much energy. Also, we can measure energy efficiency ratio and power usage effectiveness for different type of network. However, the power consumption monitoring on the network device is not sufficient, because for monitoring is just to focus on how much energy or power can be consumed on specific network device. But we also need to care about where and why consume so much energy, and what measure we can take to reduce energy consumption for specific location. And to tackle this challenge, actually, energy efficiency and management can be already become the technology trend. So this really allow network operator to optimize the energy usage based on discovered capability. In the meanwhile, really can help improve overall network utilization. And the energy efficient observability really provide global visibility to not only network topology data, but also inventory data, power data, and energy data, actually allow easy and flexible correlation and mapping for various different type of data. So the bulb of the green actually is kind of working forming bulb, and it's really targeted to create a working group, and the focus is green bulb to explore what information can be exposed using young data model, and what the requirements look like for the energy efficient management. And actually, we will really have used this to address the challenges faced by today's network operator. So this green bulb we organized on Wednesday afternoon, the first session. So it's a 2-hour discussion. So your input, for like concrete input on the use cases, report usage, like government regulation method, rules. Actually, also ongoing work in some other SDO will be welcome to And if you are only interested, to target to like environment impact program, actually green bulb is not the right place to go. Yeah, thanks for listening.
Right on time. Well done. And last but not least, Corio and Giulio. Ready? Good.
Hey everybody, I'm Giulio. I work at the Freedom of the Press Foundation, which is an NGO that tries to develop safe tools for journalists. We have historically been developing and maintaining SecureDrop, which is one of the most widely known whistleblowing platforms, open source. SecureDrop, like most of whistleblowing platforms in use today, have this kind of model where there is a centralized server held by the whatever institution is looking for leaks. It could be a newsroom, it could be a private or public entity that has to comply with whistleblowing laws in Europe on specific regions. And at the moment it works like this. So there is a centralized server, and there's then Tor encryption in transport, and there's generally 2 types of users: source, which are people who want to leak stuff, and journalists who are supposed to receive that. And historically, this hasn't really had any complete end-to-end encryption from source to journalists for a lot of reasons. But right now, this is the kind of state of things, and it's the state of things for most solutions. The commercial ones actually don't even implement encryption most of the times. And we've been trying to redevelop this to bring true end-to-end encryption, but the problem is that most messaging protocols nowadays don't really fit this use case because they're mostly aimed for mass instant messaging, think Signal or Matrix, while our threat model is relatively different from that. And in this, we have kind of different goals. We can really have client applications. We have to stick to web browser mostly because that's a usability constraint. At the same time, we can really have key material on the source side, and we want to actually have really as little as metadata as possible because volumes are pretty low. Imagine maybe a submission for a server in a week. So messaging volume is very, very low. And so we have some kind of trade-off where we don't really need real low latency. We don't need a lot of traffic. At the same time, we have some more goals, especially about metadata. We don't want to store recipient or sender information, but at the same time, we don't want to leak anything about the state of the server because that's still metadata and someone could know if, for instance, we do trial decryption, so we broadcast encrypted messages and we allow clients to do trial decryption locally. At that point, we would have other threat model implications. And so we have tried to develop kind of our own thing. This is just a quick tease, just to show that we are compromising some properties such as scalability of groups in favor of other properties, just to overstate that current protocols don't really fit our niche. This is still a tease, but what's most important is the open question for us. First is to understand if there could be other use cases for what we are doing. Think maybe where regulation doesn't reach, especially in the European Union, and whistleblowing platforms are quite not so security well done. If actually a technical solution could help in that, if there are post-quantum experts, we have some problem at porting some part of the protocol in the post-quantum world. At the same time, we're not entirely sure that our threat model is the perfect one for this use case, and many more. And to just add that this work is in progress, but we've done a cryptographic audit. It turns out to be quite okay. Someone at an institution brought the manual security proof. Someone at ETH Zurich, Luca and Felix are working on a Tamarin model. We have funding for this. And this is our contact information. Come and for us if you have anything to say, if you want to look at that, if you have idea if this can actually be useful beyond us. And yeah, that's all.
Thank you, everybody, for being incredibly efficient, which leaves you with extra time to chat with each other in the hallway or in this room if you like, and extra time to get to dinner. Thank you for joining us. That's all I was required to do.
Nice to introduce. Yes.
You know, a little leak. We're done.